I want you to think, like really think, about the last time you signed a highly sensitive digital document.
Oh, yeah. We've all been there.
Right. I mean, maybe it was a mortgage application or an employment contract or even just a massive non-disclosure agreement for your business.
Yep.
You read it over, you type your name, you pick one of those, pre-generated cursive fonts.
Ones that look nothing like your actual signature.
Exactly. And you click that satisfying I agree button, the screen flashes green, and you're done. Or, well, you think you're done. But I really want you to ask yourself, where did that document actually go?
It's a question we almost never ask, honestly, because the friction has been deliberately designed out of the whole experience.
Yeah, it's just so seamless now.
Right. The user interface is built to make you feel like the document is just, living right there on your screen. But the reality of where that sensitive data actually ends up, well, it's pretty unsettling when you pause to consider the actual mechanics of it.
Like, whose servers is that mortgage sitting on right now? Who actually holds the encryption keys to that specific server farm in the middle of nowhere?
Mm-hmm.
Usually the answer is some massive third-party cloud provider. You are essentially taking your most confidential information and just willingly handing it over to a middleman.
And if you zoom out, the entire global digital signature industry basically relies on this exact model of centralization.
Right.
We surrender our raw data to external platforms, allowing them to ingest it, to store it, to hold it, simply to prove to another party that we agreed to a set of terms.
It's wild when you say it out loud.
It is. I mean, it is a massive single point of failure.
Okay, let's unpack this, because today's deep dive into our source material, which is this really fascinating white paper and a pretty dense set of architectural documents, is going to completely flip that script.
It really does.
We are exploring a system called Air Gap Sign, or AGS for short. And their mission is just this radical new paradigm in digital agreements. They actually call it the quiet architecture of trust.
I love that phrase.
Me too. Because if the traditional digital signature industry is basically a giant, fundamentally insecure filing cabinet sitting in the middle of a crowded public plaza, AGS is promising to just remove the filing cabinet and the middleman entirely.
Yeah, the traditional model operates on a very simple, kind of arrogant premise, which is, give us your document, we will keep it safe on our servers, and we will broker the trust between you and the other party.
We promise we won't look.
Right, exactly. But the AGS architecture completely reverses that. Their premise is, keep your document, we actively do not want to see it.
Wow.
Yeah, they say, we will broker the trust between the parties using mathematics alone. It's a fundamental unwinding of how we have handled digital negotiations for the last, 2 decades.
Which brings up, honestly, an immediate logistical nightmare in my head. How do you negotiate and sign a contract on a platform that actively refuses to look at the contract?
Yeah, it sounds impossible at first.
It does. To understand this, I think we have to start at the very beginning of their process, which the architectural documents call the zero-knowledge baseline.
Right. And this is built on a concept called decentralized document control. So the absolute core rule of the system is that your documents stay completely local to you.
Meaning on my actual laptop.
Exactly. They never go to the cloud. They stay on your hard drive, your local machine, or, your law firm's secure internal network. At no point does the AGS platform ever ingest, store, or process the raw text of your sensitive proposals.
But wait, if they never inject the document, the platform is flying blind. They literally have no idea what we are negotiating.
Yes and no.
Okay, because according to the sources, the first step is something called minted asset integrity verification. And this relies on a cryptographic fingerprint. I want to try an analogy here to kind of ground this for you.
Go for it.
Okay, imagine you have a highly confidential physical document, right? And you lock it inside this heavy titanium briefcase. You don't send the briefcase to the other party, and you definitely don't send it to the platform.
Right, the briefcase stays with you.
Exactly. Instead, you take a unique, hyper-precise 3D scan of that briefcase. So you're measuring its exact weight down to the microgram, its dimensions, its magnetic resonance, all of that.
Okay.
You then publicly register that scan on a digital ledger. So I don't know what secret is inside your briefcase, but because I have that scan, I will know instantly if you try to secretly swap it out or, tamper with it in any way.
That's spot on. In digital terms, that 3D scan is what we call a cryptographic hash.
Okay.
It's a unique fixed-length string of letters and numbers that's generated locally on your own computer.
So it's perfectly unique to that specific file.
Exactly. If you take a massive 200-page contract and you change a single period into a comma, the math completely changes, and it generates an entirely different hash.
Wow, just from one comma.
It's just a comma. And you send only that hash, just that string of numbers, to the AGS platform, which then anchors it on-chain.
And we should clarify here for the listeners, when we say on-chain, we aren't talking about volatile cryptocurrency.
No, definitely not.
We're talking about a public, unchangeable ledger. It acts more like an automated mathematical notary public.
That's a great way to put it. By doing this, you are establishing an absolute tamper-proof baseline for the negotiation without ever exposing a single word of the sensitive data to centralized compromise. This is the whole foundation of their zero-knowledge trust model.
There is this quote from the source material that really summarizes this first step perfectly. It says, "Before either side speaks, the record already exists." And it actually goes on to call this a starting point neither side can quietly rewrite.
Because if you think about the messy reality of traditional corporate negotiations, it's chaos.
Oh, absolutely.
You have Word documents flying back and forth over email between like a dozen different lawyers. You have version 2 final, version 2 final, really final.
With my initials, your initials, a date string that makes no sense.
Exactly. And in all that chaos, it is incredibly easy for a crucial liability clause to be accidentally deleted. Or, for someone to quietly change a number, hoping the other side's junior associate just doesn't notice.
Right.
By minting that integrity fingerprint before the negotiation even starts, you eliminate that entire category of risk completely. The math proves the starting line.
Which is brilliant, but locking the starting point in a digital briefcase creates a massive hurdle, though. I mean, if the platform is blind to the document and the exact text is locked down locally, how do you actually negotiate?
Right, because things have to change.
The terms have to change. We can't just agree on the very first draft.
Well, this brings us to what the architecture calls the living agreement room, or the LAR.
The LAR.
It is this environment designed specifically for high-integrity, cross-border deal-making. And the governing philosophy here is that the negotiation writes its own record as it happens.
So inside this room, the white paper describes these dynamic artifacts being generated. Things like the living deal sheet and the living master understanding agreement, or MUA.
Yeah, the MUA.
And these documents are updating instantly, reflecting every single change in real time, maintaining a full version history, and they remain editable until the finalization.
Yes.
There is even a strict rule on voice calls, which I found fascinating. You can jump on the phone to hash things out, but any verbal agreement made on that call absolutely must be confirmed in writing inside the LAR.
Oh, yeah. They are very strict about that.
If it is not logged in the room, it literally does not exist in the audit continuity.
But I have to push back here. There's a huge missing piece.
Okay, what is it?
The sources mention an AI-mediated conflict reduction feature that actively works to prevent deal break risk. Wait, if the system's perfectly zero knowledge, the AI can't read the text either, right? It cannot. The system is entirely blind to your 200-page localized PDF.
Then how on earth does an AI mediate a conflict or generate a detailed deal sheet? If it is completely blind to the secret terms of the contract, what is it actually analyzing? Wait, earlier you mentioned it processes pseudonymous negotiation history.
So is it just looking at the skeleton of the deal, like the numbers, the dates, the structural parameters, rather than the actual meat of the legal text?
Yes. What's fascinating here is how they manage this separation. Think of it like a game of Battleship.
Okay, Battleship.
You can't see the other player's board, which is their underlying document, with all the deeply confidential trade secrets and employee lists, but you can communicate specific coordinates.
I see.
The parameters of the deal, like the purchase price, the closing date, or the liability caps, are agreed upon as pseudonymous terminology that is minted on the ledger. So when you argue with the counterparty inside the LAR, you are arguing over these specific verified parameters. Oh, so the AI sees that party A's parameter for the purchase price is, let's say, $125 million, and party B's parameter is $110 million.
Exactly.
And it can mediate that gap based purely on those structural inputs without ever needing to read the underlying confidential files that actually justify those numbers.
Precisely. The architecture masterfully separates the act of agreement from the content of the agreement.
That is so smart.
It really is. The LAR functions as a living negotiation ledger. It captures every move, every counteroffer, every agreed point, without ever centralizing the sensitive material itself. It keeps the messy human negotiation organized and structured, but entirely private.
So the AI bridges the gap on the parameters. We have a final living deal sheet and everyone is happy. But eventually, this has to turn back into a massive, legally binding document.
It does.
Normally, this is the exact moment where you are forced to give up and just upload the final 200-page PDF to a cloud server to get everyone's digital signature on it.
But doing that would defeat the entire purpose of the zero-knowledge architecture.
Right. So how do they do it?
AGS handles this transition through a process called the lawyer finalized agreement phase, followed immediately by air gap execution. It actually starts off-platform.
Off-platform, yeah.
The authorized drafter takes that final living master understanding agreement and the deal sheet, and they produce the final PDF contract externally on their own computer. They just use whatever standard word processor they prefer.
So they're just using Word or whatever to draft the final thing.
Yeah.
I guess the human expertise ensures the nuance isn't lost in translation from the negotiation room to the final legal prose.
Exactly.
And once that final PDF is ready, it is distributed to all parties privately. So maybe via encrypted email or a secure local law firm network. And this is what triggers the cryptographic verification step.
Yes. When the signer receives that final document, they load it locally into their AGS signing layer. And the system instantly computes a brand new cryptographic fingerprint for that final PDF right there on their computer. It then checks that new fingerprint against the entire mathematical history of the negotiation that was recorded on the public ledger.
Okay, here's where it gets really interesting. The math essentially acts as an automated bouncer.
Mm-hmm.
The source material states it plainly. It says, nothing gets signed that hasn't already proven itself.
Such a powerful concept.
Right. If there's any edit to that final document, like we said earlier, a single comma added, a margin adjusted, a zero quietly removed from a payment clause off platform, it triggers a fingerprint mismatch.
An instant rejection.
The system recognizes that the document on your local machine does not match the mathematical consensus of the negotiation, and it simply blocks the signature. It will literally not let you sign it.
Which is amazing because you don't have to rely on some exhausted junior associate staying up until 3 a.m. doing line-by-line comparisons to make sure the other side's lawyers didn't sneak in a rogue clause.
Nobody wants to do that.
No one. And if the fingerprint perfectly matches the ledger, the document opens on your machine and it's sealed for sovereign local signing.
Okay, so the physical act of signing happens on your own device. In this ecosystem, signatures rely on private keys, which are essentially highly secure, hardware-bound digital ID cards stored only on your local computer.
Right.
Those private keys never touch the AGS servers. There's no centralized database holding your signed contract. The system just takes the verified final fingerprint, the pseudonymous negotiation history, and the signature event itself, and binds them together into a single permanent asset on the ledger.
It just creates an undeniable mathematical proof that you agreed to a specific document at a specific time without them ever needing to hold the document itself.
That is wild.
When we talk about the concept of digital sovereignty, this really is its ultimate expression. The AGS white paper summarizes it beautifully. They write, "Nothing to hand over because nothing is held."
Wow.
Yeah. The platform operates as a trust anchor and a mathematical referee rather than a document repository.
Taking the middleman out fundamentally changes the security profile of doing business digitally. That much is obvious. But there is a massive secondary effect here that the white paper spends a surprising amount of time on, and that's the physical footprint of digital trust.
Oh, the environmental impact.
Yes.
Right.
If we have a perfectly secure, locally signed, zero-knowledge contract, it means we don't have massive files sitting in cloud storage.
The environmental costs of our current digital infrastructure is a massive, often ignored issue.
Definitely.
When you upload a heavy 50-megabyte PDF to a centralized cloud, it doesn't just sit statically on one server.
Right, it gets copied.
To ensure uptime, it is replicated across multiple server farms for redundancy. It is constantly backed up. Those servers require massive industrial cooling systems to prevent overheating. Furthermore, the documents are often continuously scanned and indexed by server-side AI models for text extraction and analytics.
Just constantly burning energy.
All of that consumes continuous, immense amounts of power.
The stats in the white paper are actually wild. By removing the need for cloud storage, the AGS architecture has a roughly 400 times smaller footprint than industry standards.
That's a staggering number.
It is. Per contract, a traditional centralized signature process generates between 220 and 413 grams of carbon emissions. The AGS process generates just zero point 0.4 to 1 gram.
Wow.
That translates to a 99.9% reduction in storage emissions. Network transfer drops by up to 99%. AI compute drops by up to 98%.
Because the system is just transferring tiny strings of cryptographic text, those fingerprints, instead of lugging around heavy PDF files and constantly pinging databases.
Exactly.
The math is computed locally using a fraction of your laptop's CPU for a millisecond rather than firing up a massive water-cooled server farm in another time zone.
Right, and to put that in perspective for you, if you are a mid-size enterprise executing, say, 100,000 contracts a year, the traditional method generates between 22 and 41 tons of emissions.
Huh.
With this decentralized architecture, it drops to between 40 and 100 kilograms. So what does this all mean? If you are running a business, you aren't just protecting your data from hacks, you are instantly slashing your corporate carbon footprint just by changing how you sign paperwork.
It is a profound efficiency gain. But if we connect this to the bigger picture, the unseen meta-benefits go far beyond just environmental sustainability.
Okay, where are we going with this?
The shift away from centralized data storage creates an incredible regulatory and geopolitical shield.
Oh, the compliance stuff.
Right.
The compliance alignments listed in the documents are extensive. Because the system doesn't hold data, it naturally satisfies some of the strictest data laws on the planet.
Yep.
They list European cyber resilience frameworks like NIS2 and DORA, alongside strict privacy laws like GDPR and the EU AI Act, right alongside American healthcare protections like ACHITO. But the real revelation is what it actually prevents exposure to.
This is the crucial part.
Because AGS holds zero data, it completely neutralizes exposure to FISA 702 and the Cloud Act.
This is a seismic shift for international business because the Cloud Act and FISA 702, those are U.S. laws that essentially grant American intelligence and law enforcement agencies the power to compel U.S.-based tech companies to hand over data.
Even if the data isn't in the U.S.
Crucially, yes.
Yeah.
They can demand this even if that data is physically stored on servers in Europe and even if it belongs to non-U.S. citizens.
That's terrifying for foreign businesses.
Yeah.
So imagine you are a German engineering firm signing a highly classified trade secret agreement with a supplier in France. If you use a traditional American digital signature cloud to execute that document, you are technically vulnerable to those U.S. surveillance regimes, simply because the cloud provider is headquartered in the United States. It's a massive point of anxiety for European corporate sovereignty.
And European regulators have been scrambling to find solutions to this, pushing heavily for sovereign clouds and strict data localization laws. But the AGS architecture just sidesteps the entire geopolitical fight.
Because there's nothing to give them.
Exactly. A foreign government cannot compel a software company to hand over data that the company literally does not possess.
Right.
By decentralizing the document control and utilizing a zero-knowledge trust model, AGS renders those cross-border data access laws entirely moot. It is the ultimate regulatory shield because the sensitive content never leaves the sovereign control of the users.
It is a really elegant solution to a very messy international problem. You just take the target off your back entirely. Well, we've covered a lot of ground today, from the mechanics of cryptographic hashes to server farm energy consumption, all the way to international data law. So let's wrap this up and kind of bring it all together.
I think the journey we've taken today through these architectural documents really illustrates a fundamental evolution in how we establish trust.
Yeah.
We are moving away from a world where we had to blindly trust the giant filing cabinet in the public plaza, hoping the guards don't read our files, hoping the cabinet doesn't consume massive amounts of electricity, and hoping a foreign government doesn't demand the keys.
And we are moving toward a sovereign zero-knowledge architecture, a system where math basically replaces the middlemen. The core takeaway from everything we've looked at today is simple but really profound. Knowledge and trust can absolutely be verified without ever being exposed.
Beautifully said.
You can mathematically prove a document is authentic, you can prove a negotiation happened fairly, and you can execute a legally binding signature, all while keeping your secrets entirely your own.
It completely rewrites the risk profile of doing business digitally.
It really does.
Oh.
But looking at all these structural changes leaves me with a final, slightly provocative question to chew on, something that builds on the implications of everything we've discussed.
Oh, let's hear it.
We've established that this architecture creates a mathematically undeniable, perfectly preserved cryptographic ledger of every single version, every counter term, and every final signature, right?
Right.
If a contract is forged in a system like this, where tampering is physically impossible and the audit trail is absolute to what actually happens to traditional corporate litigation.
Oh, wow. It creates a fascinating existential problem for the legal industry.
Right. Because so much of corporate law and the billable hours that come with it is spent arguing over who said what, which version of the contract was actually the final one, or whether a signature was coerced or altered after the fact.
It's all about the gray areas.
Exactly. If this technology makes the entire history and execution of an agreement mathematically undeniable, does it essentially make the traditional breach of contract lawsuit obsolete before it even starts? If the math proves who is right instantly, there's no muddy water left for the lawyers to fight over.
That is a very interesting thought experiment.
It's definitely something for all of us to mull over the next time we're asked to blindly click I agree and just send our data into the void.
A quiet architecture indeed.
That's all for today's deep dive. Stay curious.